Hello guys and welcome all of you, and after finishing first chapter, that is force, we are going to start new chapter, that is pressure. So first question in your mind, sir, what we study in chapter? So let's see the syllabus. So according to your syllabus, first one is introduction to pressure, then after Pascal's law and its verification, then after hydrostatics pressure, Archimedes principle and its application, and last part is numerical problem from Archimedes principle and pressure and law of flotation. So these are your syllabus and we will discuss one by one, series by series, so there is no any confusion between the videos because each video are numbered by a specific name, that is 1 2 3 4. So let's talk about pressure. So what is the definition of pressure? So pressure is defined as force exerted by a body per unit area. So what is the formula of pressure? So its name suggested, force exerted by a body per unit area. So pressure equals to force by area. So it means that pressure is directly proportional to force. So pressure is directly proportional to force. And second case is pressure is inversely proportional to area. So what is the meaning of directly proportional to? What it stands for? What is meaning? So pressure is directly proportional to force. It means that when we increase the force, this quantity, then pressure is also increased, and when we decrease the force, then pressure is also decreased. And second one, what is the relation between pressure and area? This is inverse relation. It means when area is small, then pressure is increased, and when area is big, then pressure is small, that is pressure get decreased. So what are the application of this formula? So let's talk about three short so give reason. So first one is example, a sharp knife cuts better than a blunt one because the area of the sharp edge is much lesser than the area of blunt edge. For the same force, the effective force, that is a pressure exerted by a sharp knife, is more than the blunt knife. So it is easy to cut any vegetables as well as other things from sharp knife than blunt one. And so second one question is, railway track are leads one large size wooden sleepers. The large size wooden sleeper have great surface area. So listen, so large size this wooden has great surface area. So when great surface area, it means high surface area, so the pressure is decreased. So the pressure is decreased, so the it is easy to move the rail, because it is impossible to go to this when you reduce this area, then pressure is decreased, so uh, the railway track do not go to the soil, and this is the reason behind the idea. So what is the unit of pressure? So what is the formula of pressure? Pressure equals to force by area. So what is the unit of force? Newton. And what is the unit of area? Meter square. So what we write, Newton per meter square. And this pressure, about most of the concept of pressure was given by a scientist, that is Pascal. So the unit of pressure is also called Pascal, and it is denoted by PA in bracket. So then after our your syllabus, liquid pressure. So here I am not going to describe the derivation of liquid pressure, but it is a bit only essential in class 9. We are already talk about this derivation of liquid pressure. But simply, what is liquid pressure? So liquid pressure is defined as the pressure exerted by liquid on the base of the container is called liquid pressure. Again one time, the pressure exerted by a liquid on a base of container is called liquid pressure, and the formula of liquid pressure is pressure equals to HdG. So liquid pressure P equals to HdG. So what is it means? That it means that liquid pressure is directly proportional to H, means height or depth. So when depth is increased, then pressure is increased, and when depth is decreased, then pressure is decreased. And second one relation, pressure is directly proportional to density. So what it means? It means that when the substance whose density is more, then exert more pressure. For example, mercury and water. So which one have more density? So mercury have of course more density. So mercury exert more pressure than water. And when the substance whose density is less, then it exert less pressure. And third relation is pressure is directly proportional to acceleration due to gravity. And you know the acceleration due to gravity is not a variable quantity. It means that it changes according to surface of the earth. So the when acceleration due to gravity is increased, then of course pressure is also increased, and when acceleration due to gravity is decreased, then pressure is also decreased. So that is the relation between liquid pressure and the acceleration due to gravity. Okay, so then after last one is atmospheric pressure. So earth is surrounded by a envelope of air, and that is called atmosphere. So what is atmospheric pressure? So the pressure exerted by a air in unit area are called atmospheric pressure. Unit area is called atmospheric pressure. So pressure exerted by air in unit area, here spelling mistake, that is area, area. So in unit area is called atmospheric pressure, and this atmospheric pressure is measured by barometer. And a standard atmospheric pressure, that is 1 atm equals to 760 mm of Hg. So 760 mm of Hg. So what is the definition of 1 atm pressure? How can we define this definition of 1 atm pressure? So the pressure exerted by 760 mm means how much centimeter? 76 centimeter, or 0.6 meter long column of here long column of mercury at 0 degree Celsius. So at 0, the pressure exerted by 760 mm means 76 cm, or 0.7 meter long column of mercury at 0 degree Celsius at sea level at the altitude of 45 degree is called 1 standard pressure, or 1 atm pressure, or normal pressure, that is 760 mm of Hg. So in this is the, so how can we convert this 760 of mm Hg into a standard unit, that is SI unit? So what is the formula of pressure? Liquid pressure HDG. So H means how much? 760 mm. So that convert mm into meter, that is 0.7 meter. So H, and the D means where we take mercury. So what is the density of mercury? 13600. And G means acceleration due to gravity, average 9.8. So then we multiply, what we get? 1.01 into 10 to power 5 Pascal. So this is the all about the introduction part of the pressure. Now question 1 arises, or what is 1 Pascal pressure? So 1 Pascal pressure is defined as the pressure exerted by a body having 1 Newton force on 1 meter square area. So when I put here 1 Newton force and 1 meter square area, then we get 1 Pascal pressure. So the 1 Pascal pressure is defined as the pressure exerted by body in one applying 1 Newton force on unit area is called 1 Pascal pressure. So this is the all about the introduction part of the pressure, and in coming lecture, that is the second lecture of the pressure, we are going to discuss about the Pascal's law and other topics. And thank you for watching.